This is for Algebra 2, and this is starting our exponential unit. We're going to quickly remind ourselves of the exponent rules. When you are multiplying like terms, okay, they've got to have the same base. You simply add the exponents. It would be m plus n. So 3 to the 4th times 3 to the 5th becomes 3 to the 9th. X to the 7th times x to the 9th becomes x to the 16th. B to the A times B to the C becomes B to the A plus C. So basically, to multiply terms that have the same bases, you can add your exponents. When you have one that looks like a fraction, you're going to say A to the m minus n. So 4 to the 7th over 4 squared becomes 4 to the 7 minus 2 is 5. X to the 17th over x to the 21st becomes x to the negative 4th. But we do not want a negative exponent, so it goes to the bottom, and it's 1 over x to the 4th. To divide terms, because that's what a fraction is, with the same base, you simply subtract the exponents. When you're raising a power to a power, it's going to be a to the mn. 3 to the 4 times 5 is 20. 5 to the negative 2 times 8 is negative 16. We do not want a negative exponent, so you move it to the bottom. X to the 7 to the 3rd becomes x to the 21st. So to raise a power to a power, you multiply your exponents. Even though we've already kind of talked about it, here it says a to the negative n becomes 1 over a to the n. You do not want a negative exponent. You move it to the other part of the fraction to make it positive. So 10 to the negative 5 is 1 over 10 to the 5th. 5 to the negative 1 is 1 over 5. X to the negative 7 is 1 over x to the 7. You only move the term or the variable that has the negative exponent. Negative exponents mean reciprocals, or I like to think that you're going to move to a different part. So here's a new one. If we have a fraction for our exponent, a to the 1 over n, this becomes the nth power of a. So the denominator of that fraction is your root. 81 to the 1/2 is the square root of 81, which is 9. 16 to the 1/4 is the 4th root of 16, which is 2. X to the 1/5 is the 5th root of x. So a rational or fraction exponent means that you're going to have roots. A to the m over n, if you have a fraction up there with numbers in both or letters in both, it's the nth power of a to the m. So 81 to the 3/2, it's the square root of 81 to the 3rd. 16 to the 3/4 is the 4th root of 16 to the 3rd. X to the 2/5 is the 5th root of x squared. And on this one, I would actually probably write it this way. So basically, for fraction exponents, the numerator is a power and the denominator is a root. A to the n equals a to the m. Then n is equal to m. If you have your same base and they're equal to each other, your exponents have to be the same, which leads us into making equations. If you have 5 to the 2x minus 1 is equal to 5 to the 7, our base is the same, so the exponents have to be the same. And you would just make a normal equation. 2x minus 1 equals 7. Add your 1, so 2x is equal to 8, divide by 2, and x equals 4. Now, you have to have the same base for that to happen. So on this one, you've got a base of 9 and a base of 3. You've got to first rewrite this one as 3 squared. So it's 3 squared to the x minus 3. Then you got to remember, a power to a power, you're going to multiply, okay? And it becomes 3 to the 2x minus 6 equals 3 to the 4th. Our bases are the same. You make an equation, 2x minus 6 equals 4. Add your 6, 2x is equal to 10, divided by 2, and x is equal to 5. So you can solve for variables in exponential equations if both sides have a common base. It's got to be a common base. You've got to get it to a common base or something. Otherwise, you can't make that equation. Turning the page. So we know that a monomial is one term. There's no plus or minus. A constant is just a number. A coefficient is a number in front of a variable. The degree of a monomial, you add the exponents. if you can read my writing there. And like terms have the same variable and same exponents. Okay? X to the third and x to the fifth are not like terms. Okay? So which of the following are monomials? This is not because of the plus. This one is. This one is. This one is. A monomial cannot have a fraction or a negative exponent. So this is not. But you've got a number in the bottom. That's just like saying 1/2 x, and so this is. Example 2, which monomials are constants? Remember, a constant's just a number, so that's not. That one is. That's not because of the letter. That one actually is. That one is. That one's not. What is the coefficient? Remember, the coefficient is the number in front. So it's 3. It's -4. It's 5. It's 1. When there's not a number there, it's like 1x. Think about what's in front of the entire x. It's going to be 2/3. And this is going to be -1/2. What is the degree? You take your exponents and you add them. 3. 2 plus 3 is 5. 1, 2, 3. 4 plus 1 is 5, plus 3 is 8. 1 plus 1 is 2, plus 10 is 12. This one does not count because that's part of your coefficient. 5 plus 5 is 10. Combining like terms, we have x squared, so 3 plus 4 is 7. It stays x squared. We have -2x plus x. -2 plus 1 is -1, so minus x. And then -5 minus 10 is minus 15. Going to the next page. Okay, this is kind of a repeat, a summary, if you will. If you're multiplying, this would become a to the mn. Power, no, my bad. If you're multiplying, you add your exponents. This becomes a to the m plus n. Power to a power, you multiply. I think we're just going to write this out there. I think that'll be better. Add, you're going to multiply. You're going to subtract. You're going to multiply. Anything to the 0 power is 1. I don't think we've talked about that. Negative exponent, you're going to move. You're going to move. And power to a power, you're going to multiply. So, if you're doing something like this, you're combining like terms. X squared y, x squared y. 3 minus 4 is a negative x squared y. Xy squared and xy squared go together. 4 plus 6 is 10, so plus 10 xy squared. These are all x to the fifth, so they can all be combined. 12 minus 2 is 10, plus 11 is 21, minus 1 is 20, x to the fifth. A squared b to the third, these are both that. This one's not. 5 minus 2 is 3, a squared b to the third, plus 3a to the third b squared. 2/3 times -9/8, it's going to be negative. Your 2 and your 8 cancel and leave you 4 on the bottom. 3 and your 9 cancel and leave you a 3 on the bottom. So it's -3/4, and then add your exponents, so a to the 7th, b to the 7th, c to the 4th. -2 to the 4th, when you put this in your calculator, make sure you put your -2 in parentheses and then rooftop 4, and you're going to get 16. And then x to the 2 times 4 is 8. Once again, put your -3 in parentheses and then rooftop 3, and so that would be a -27, x to the 3rd, y to the 6th. You're multiplying your exponents. This is a little confusing because your base is a number. Your base is your base, and it always stays the base. So your base is 2. 25 plus 10 is 35. I don't want a negative exponent, so the whole thing goes to the bottom, and it's 1/3 to the 4th. 3 to the 0. Okay, so 0 times -2 is 0. It's gone because anything to the 0 power is 1, so it's just kind of gone. X to the 10th. And you would have y to the -12th. Let's go ahead and move that to the bottom because I don't want a negative exponent. Negative 2 to the 4th is 16. This would be a to the 4th, b to the 8th. Last page. 8 times 3 is 24. Add your exponents, x to the 6th. Negative 5 times 3 is negative 15. Add your exponents, x to the 10th. 10 times 9 is 90. Add your exponents, 2 plus 3 is 5. 5 plus 1 is 6. Negative 8 times negative 8 is a positive 40. X to the 12th, y to the 18th. 9 times 8 is 72. X to the 12th, y to the 18th. 30 over 5 reduces to 6. 10 minus 3 is 7, so 6x to the 7th. 55 over 11 reduces to 5. 6 minus 2 is 4, so x to the 4th. 80 divided by 4 is 20. 5 minus 2 is 3, so x to the 3rd. 7 minus 3 is 4, y to the 4th. Negative 70 over 10 is negative 7. 8 minus 3 is 5, so x to the 5th. 10 minus 7 is 3, y to the 3rd. 10 over 4 reduces to 5 over 2. 8 minus 2 is 6, and so x to the 6th in the top. Your y to the 5th is going to cancel. 20 over 30 reduces to 2 over 3. X to the 3rd cancels. Y to the 8th over y to the 7th leaves you y. Okay, I believe that's all of your notes, and so that will take you to your assignment. The exponent rules are on the wall, or you can look at your notes. Come ask me if you have questions.